Hello everybody, welcome back to another video with Learning with Jess. And today, in this video, we are going to be covering basic trigonometric identities. We're going to be learning about the basics of sine, cos, tan, secant, cosecant, and cotan. Let's get into this video. First up, we have our basic Pythagorean identity. We have sine squared theta plus cos squared theta is equal to 1. How do we prove this? Well, we have our triangle here. It's a random right triangle. And we have an angle here that's called theta. First of all, we're going to find the sine of theta. And basically, if you don't remember what sine of any angle is, it's basically opposite over hypotenuse. So for sine, it would be B over C. Now we're going to find the cos of theta. And basically, if you don't remember what that is, it's basically adjacent over hypotenuse. So that would be A over C. Now, since that sine squared and cos squared are since that sine and cos are both squared, we're going to have to square our values. So sine squared would be b squared over c squared, and cos squared would become a squared over c squared. Now, since that both of these equations have the same denominator, we can put them together. This would become a squared plus b squared over c squared. Now, if you guys don't know this, there's something called a Pythagorean theorem. This is basically used for all right triangles. And what that means is a squared plus b squared is equal to c squared, which is our hypotenuse. So since a squared plus b squared equals c squared, we can immediately put that as c squared. And since c squared over c squared, and now we have c squared over c squared, which is equal to 1. We can use this equation to prove any other identities. Keep doing operations until you prove what you are looking for. This is our first identity. This is called the secant and tan identity. We have our equation here. Now, if you guys don't know what secant is, it's basically the reciprocal of cos. So that would be 1 over cos of theta. So in order to find our identity, we're going to divide everything by cos squared theta. So let's do that. Sine squared theta over cos squared theta plus cos squared theta over cos squared theta is equal to 1 over cos squared theta. Sine squared theta over cos squared theta would become tan squared theta because the tan is equal to the sine over cos. Cos squared theta over cos squared theta would become 1. And 1 over cos squared theta would become secant squared theta. This is our identity that we have just found from using this identity here. Now, let's go on to a different identity. Cosecant and cotangent. This time, the cosecant is 1 over sine, and cotangent is 1 over tan. So this time, we're going to use our equation and divide by sine. So what we're going to do is we're going to do sine squared theta over sine squared theta plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. Sine squared theta over sine squared theta is equal to 1. Cos squared theta over sine squared theta is equal to cotangent, which is basically, which I just said, is the reciprocal of tan, so it would be cos over sine. 1 over sine squared theta becomes cosecant. And this is our equation and this is our identified equation from this equation here. Now we have one more. This is called the law of sines. We have a random triangle here. It's called A, B, C. Imagine if we were to draw a perpendicular line. We call this perpendicular P. Now we have two right triangles. Our first right triangle is triangle BCD. And our second right triangle is called ACD. In order to use the law of sines, we're going to find the sine of B and the sine of A. So the sine of B would be P over A because it's opposite over hypotenuse. The sine of A would be P over B. Now what we can do is we can put those together, we can set them equal to each other, and we can cross multiply. So therefore, A times sine B would be equal to B times sine A. Also, this is our equation that we use in order to find the law of sines. Now, unfortunately, we are out of time to find the projection formula, but I will leave this as an exercise. You can try to prove this using the previous example that I've just shown. You can use this triangle to find this projection formula, but this time I want you guys to find the cos of A and the cos of B. Right here. A would be equal to B times the cos of C plus C times the cos of B. Now that is all for today's video. Thank you guys so much for watching, and be sure to like and subscribe. Continue learning, and I will see you guys in a future video. Thank you from Singapore, even though I'm not in Singapore, it's just a joke. But that's all from Learning with Jess. See you guys next time.